Hi, this is already part 2 of Graham's law of effusion problem solving. And in the previous video of part 1, we stopped with this particular problem in which we're given the rate of a certain unknown gas to that of nitrogen gas. And we were able to end up with making an equation from the given statement that the unknown gas has a rate of 0.462 times of the nitrogen gas N2. Take note N2 because it's diatomic. And since you know that if we put all the V's there, we can get an expression of Vx over V N2 is equal to 0.462. And if we extend this to molar mass, we can say that Vx over V N2 is equal to the square root of molar mass of N2 over the molar mass of X, and which is equal to 0.462. Now we're given this, the rate ratio, and we are asked to solve for this molar mass of X. So what we need to do is we simplify this equation because we know Vx over Vn2, so that's going to become 0.462 is equal to, we focus on molar mass, square root of molar mass of N2, which we can get from the periodic table, over the molar mass of X. And because we have to get the molar mass of X, we need to find a way to cancel out units and get an expression of the molar mass of X. So clearly, we need to square both sides to remove first the square root. So we're going to get molar mass N2 over molar mass of X. I'm just going to put them to the left side. They switch places so that the unknown will be clear, is equal to 0.462 squared. So clearly, when you cross multiply this, you can get the molar mass of X. So molar mass of X, when we derive this, it's going to become molar mass of N2 over the square root of square of 0.462. And what is the molar mass of N2? Molar mass of N2 is 14.01 times 2, you'll get 28.02 over, again, 0.462 squared. Okay, now putting that in the calculator, you would get that the molar mass of X here is, again, 28.02 divided by the square of 0.462. The molar mass of that unknown gas is 131.28. And of course, what's the unit of molar mass? Grams per mole. Okay, now how do we analyze this? How do we check whether this answer is logical or not? Now take note that the given effusion rate is less than 1. So if it's less than 1 in the previous video, you know that we're talking about a gas that's supposed to be heavier than the other known gas because again, the rate ratio is less than 1. So we would expect that the molar mass of X is higher or greater than the molar mass of N2. Molar mass of N2 is 28. Therefore, comparing 28 and 131.28, of course, X is higher than 28, which makes sense. So 131.28 grams per mole is a logical answer because, again, X has to be heavier compared to your N2 gas. So again, almost all in the videos, can you please solve this one again on your notes? Put this in your notes so you can have something to go through, to review in the next days to come so that you can recall how to approach a Graham's law problem. So now we will be looking at problem number 3. Problem number 3 is still about Graham's law of effusion. And this will be the last. And this is kind of challenging. This is about effusion time. Now, before I begin with this, let us recall that when we talk about rate or V, rate of effusion is always equal to, again, amount of gas transferred per unit time. Now, when do you use this? You use this expression when you're given time. In the previous 2 problems that I gave you, there was no time. It was all ratio and molar mass. This time it's a different modification of Graham's law. This is the time that you'll be given the value of time. So let's read the problem. It takes 243 seconds for 0.000446 mole of Xe to effuse through a tiny hole. Under the same conditions, how long will it take? Same amount. If you look at that, that's 0.000446 mole of Ne to effuse. So looking at the given, let me just put the given here. You're given the T of Xe to be equal to 243 seconds. And you're given the N of Xe, which I will just make it in scientific notation. That's around 4.46 times 10 to the negative 5 mole, which is also the same with N of neon. That's just the same. And you are asked for the T of neon, the time it takes for neon, for the same amount of neon to effuse. So going back to this expression of rate, it's amount of gas per unit time, and then we relate this to molar mass. So if you start with the expression of Graham's law, so V of Xe over V of Ne, that's equal to the molar mass of Ne over molar mass of Xe. Correct? That is the expression of Graham's law. Now let's expand on the V, because we know V's formula is this. So we can expand. That's going to become amount of gas, so that's N in mole, N of Xe over the time of Xe over the N of Ne over the T of Ne, which is equal to, again, molar mass, we remove that, molar mass of Ne over the molar mass of Xe. So knowing that the N of Xe and Ne are the same, the amount is the same, so we cancel that out. Now, we would see what remains. What remains is Txe and Tne. Now, reciprocating this, because both are denominator, we're going to generate the final expression Tne. So Ne becomes the numerator because it's reciprocal, over T of Xe is equal to the molar mass of Ne and Xe. Molar mass of Ne over molar mass of Xe. We can get molar mass of Ne in the periodic table, at the same time the molar mass of Xe. And we also know the time of Xe. So we can get the time of Ne. So Tne is equal to time Xe times the ratio of the square root of the molar mass of Ne and the molar mass of Xe. Okay, now let me pause for a while. I want you to look at your periodic table, and I want you to take note of this on your notebook. And please substitute the values now. Okay? Now do that. I hope you're doing that. Okay. Okay, so now we can substitute. We can substitute our values. So molar mass of Ne, let me just put it here. Let me put it there. So T of Xe, so Tne is Txe, so that is 243 seconds times the square root of molar mass of Ne is 20.08 over molar mass of Xe, which is 131.29. I did not put grams per mole because obviously we're dividing the same value, the same unit, so you get cancelled out. So, can you please put this in your calculator? Inputting that, you will get Tne to be equal to 95.27 seconds. Okay, so we were able to get the answer. Please make sure that you already know how to solve this. 95 seconds, that means Ne should be traveling faster. I mean, faster because it's lighter, so it should take shorter time. Bye!